The world's longest subsea pipeline video series part 3. A total of 100,000 steel pipes are needed to complete the longest subsea piping installation from Norway to United Kingdom. That includes over 1 million tons of concrete and 25,000 tons of steel reinforcing. Each joint pipe weighs about 20 tons, about 10 tons of steel and 10 tons of concrete. Each of the 100,000 pipes is numbered as it comes out of the plant, destined for a specific location in the line. Watch to find more.
As the team is trenching on the steep Storegga slide, the rest of the route from the top of the slide to the shore is being prepared. This is the Island Frontier. It's a state-of-the-art trenching ship that combines two types of trenching methods into one powerful machine. They survey the flat areas where they think they can bury the pipe by scraping a trench through the sandy bottom. What they discover is not a pretty picture. The sandy bottom is actually clay, and the clay is hardened like concrete. A new digger is required to cut a channel up to 7 meters wide and 5 meters deep. The margin for error is only 50 centimeters on the width and a crucial 10 centimeters on the depth. The clay cutter hybrid, the only one in the world, is lowered to the seabed. The cutting tool uses its 24 water jets set at different angles to blast a trench through the clay. Suspended above is the 4-ton jet prop. The propeller draws in large volumes of the surrounding seawater, driving it at a high force towards the seabed, clearing debris from the trench. Transponders mounted on the sea floor relay a 3D picture of the operations to the control ship. And following along the entire operation, like a foreman on a job site, is an ROV that surveys the trench and confirms that it is dug to specifications. The battle of the clay is finally won. But when they start to lay the pipeline on the seabed, the problems really begin. The seabed under the North Atlantic is a tortuous and irregular landscape. There's over 1,000 kilometers of terrain like this along the pipeline route from Norway to England. It's so rugged that only small sections of these heavyweight pipes will actually make contact with the seabed. It's called free spanning, and they don't want it. It means the unsupported sections of pipe will sag, stress, and then break under their own weight. This would be an environmental catastrophe. They have to find some way of flattening out the pipeline route.
If you're not able to plane the seabed flat by moving the earth out of the way, you may have to fill in some holes with rock or other fill material.
They level the pipeline route by laying gravel down on the sea floor. This ship loads gravel into its cargo holds and delivers it to the area that needs leveling. It can carry over 9,700 tons of gravel at a time. Once at the job site, it uses a flexible fall pipe to place the gravel on the pipe pathway. Computers create a 3D model of the seabed and the path where the gravel needs to be placed. This method allows the crew to place the gravel precisely where they need it.
At these sort of water depths, you've got a problem because you haven't got that degree of control. I mean, whatever's doing the work down there is a huge distance away from the mothership, and they've got to still present a flat, smooth profile for the pipeline then to be laid upon. The other thing that has to be worried about is that you have to do that profiling as close as possible to the time that the pipeline is going to be laid, because Mother Nature tends to move things around again after you've left. And so you come back in a couple of weeks later and you find there's been a storm or whatever, and what you've taken so much care to flatten out has all of a sudden been moved around again. So you would lose the work that you've done before.
The pipe laying itself is a monstrous job. Once the pipe has been manufactured, it is placed onto the supply ships for delivery to the pipe laying barge, the LB200. The barge is huge, longer than 2 football fields. It's an enormous floating steel welding factory. which has to work with military precision. There are only 3 of this type of ship in the world, and Hydro is using 2 of them here.
Pipeline route has been surveyed before we ever came here. We have an ROV boat that stands by with us. It monitors the pipe as it touches seabed, and it's a predetermined route that we follow.
The barge has been used in the Gulf of Mexico, in the Mediterranean, and off the coast of West Africa. But this is its biggest and most historic assignment. Once the pipe-laying process starts, it cannot stop. Not for weather, for accidents, for anything. The pipeline is built as a continuous tube that is dropped from the ship to the seabed. If the ship halts for too long, the strain on the pipe could snap. The barge moves along at 4 kilometers a day and needs a constant supply of pipe sections, which must be delivered in the order in which they are to be connected and laid down. It's 100,000 pieces of pipe laid down end to end in a predetermined pattern.
They get moved by crane 3 or 4 times and go through about 15 or 20 welding stations and coating stations.
The pipe sections are delivered to the assembly floor, deep inside the LB200. Here the welders are divided into teams. Their job is to create sections of the pipe called double joints. These double joint sections are 24 meters long. There's a lot at stake. The pipes have to be put together so there's no chance of leakage, and the assembly line has to keep up a steady pace. The entire operation is monitored by engineers who have video cameras that put eyes on the process, both inside and outside the pipe.
It's incredible technology, but the fundamentals are very simple. The fundamental thoughts that go behind it, because it has to be so rugged and it has to work every time, first time, that the actual basic engineering is still fairly simple.
The next stage of the assembly line is to join this short section of pipe to the main pipeline. It's being fed out of the back end of the ship and onto the sea floor. It's a complex process that requires a lot of fine-tuning. This is no ordinary welding operation. The process involves a special welding machine with 8 heads per station. Passing through each of the welding stations in 7 minutes, the pipe is then checked by an ultrasound machine. If a flaw is detected, it has to be repaired immediately before moving to the next station. The process cannot be stopped. The connection has to be perfect, because this is the stage that welds them together forever. The assembly line is manned by industrial workers from over 30 countries. Shifts work around the clock to keep the assembly moving 24 hours a day. Each day, the teams have to assemble 3 to 4 kilometers of pipeline and drop it to the sea floor. After all the welding stations have linked the pipe, the final step of the operation is to seal the exposed metal. It is covered in a protective heat-shrunk plastic. Without this, the steel pipe would corrode in the seawater. Now, for the most critical step of the operation, offloading the pipe to the sea floor. The section where the pipes are joined is covered in foam to protect the welded joint during the drop. The decks are cleared and the pipe is now ready to be committed to the sea floor. A rubber tensioner grips the pipeline and holds it in place as it slides off the barge. As the pipe enters the ocean, it begins to sag and pressure is put on the entire pipeline, which is free hanging beneath the ship. Without exactly the right tension, the pipe could snap like a matchstick.
The pipe comes off the back of the barge in what's called a lazy S configuration. So it comes off the back of the barge and trails down to the seabed some distance behind. That S of unsupported pipe has to be kept from just buckling under its own weight. So to keep it under control, you've got to keep that under a huge tension to stop it from just collapsing under its own weight.
As the pipe is lowered, the barge moves forward 24 meters, not a meter more. With this well-oiled operation, the LB200 is able to lay over 100 kilometers of pipeline a month, as long as the pathway is clear. And clearing that pathway is a complicated process.